So last time we were left with that part of how to say model 5 part, right? I couldn't explain this part, which one was resolution. I'll explain that part at the end because it contains like some 4 to 5 sub parts in that. If not, I can explain that now itself. So resolution in first order logic, nothing but you have to talk about scholemization and so many things in that. So I had prepared notes in that once, so let me just scroll down and go towards that part. Yeah, this part. So see, you have to talk about, okay, first you have to talk about this conjunctive noun form. You will be connoting the given, see, originally it's this. Okay, let me highlight it properly. Okay, originally it's this. Okay, but it will become into this. You can see that, right? So here what is having, so here for all, so implication can be written as disjunctions as negations. Okay, so implications, what will happen first, wherever there is and, that's becoming or, and normal sentences are becoming negation. Only the last thing here, implication is there, that is becoming or. Okay, everything will become or here, and only negation is there, because anyways you will be writing only about this example. So if you remember this, it's more than enough. Okay, I'll try to double highlight it so that it looks okay. If I do triple highlight, it looks yeah, now we are talking. Okay, you understood, right, what I'm trying to say. Then moving negations inwards. Applied De Morgan's rule. So see here, you know already De Morgan's I said, right? If we have some letters, well, let me just draw it again. So okay, let me take white color. Okay, so negation of P. So what we have here? Okay, if it is R inside P or Q, De Morgan's rule, what it will make? It will make negation P and negation Q. Both the literals will have negation, and R will become and. Okay, so that's what will should happen. Okay, so we have here negation of for all x, negation animal y. Y is not an animal, and x does not love animal. X does not love y, or sorry, x loves y. There exists some y loves y comma x. So here what is saying? All x will love all animal y, but all animals do not love back a human. Okay, so whole thing is having negation after moving negation inwards. So see here we have for all double negation x animal y or loves x comma y, and negation there exists y, negation y loves y comma x, does not love y comma x. So here what's happening, this basically this one term. Okay, let me highlight, this thing is one term and this is another term. Okay, so this thing is one term and this thing is another term. Now what is happening, if I take another color, so here, okay, you can understand from this. So this thing is becoming this. Okay, we can see that extra double negation here. So you can simply write only animal by, you can simply skip that negation also, because double negation will become again what to say, a single negation. Okay, then if I put this, okay, I'll do like this because I don't want okay, so that's what is happening here. I'm just sorry that I'm not explaining properly, and maybe it's because it's midnight and I'm not that energetic right now. But you understand, right? This resolution first law is simply theory part. No, if you know max, you can understand. Then standardize apart variables, avoid the clashes, rename variables to ensure uniqueness. So all variables should be unique. You should not use same. So for example, you're using love, and another way you're doing loves. So only one letter difference, S, and another S is not there. So don't keep like that. Scholemma is constant. So you can see in existential quantifier, I had already explained how some letters are being like Scholemma. So see here what they are saying. For all x, there exists y, where loves x comma y means all x loves some animals, and for all z hates not hates y comma z. So y does not hate all z. Okay. After scolarization, for all x loves x comma f of x. So x loves f of x, and for all z, f of x does not hate z. So what you're doing, only y. Okay, y is being changed here. Shit. Okay, only y is getting converted into this. You can see here, right? Y was like this, it got converted into f of x. Just write one normal sentence, same thing you repeat here. This existential will drop here, but okay. Always remember, whenever you use a column is a constant, existential will drop, and just instead of y, just write a capital C1, or you can write f of x like that. Drop universal quantifier. For all x, person of x implies smart x. So all persons are smart. After dropping universal quantifier, person x implies smart x. Just this thing will get removed. Okay, nothing. Distribute over or over and, which means duality. It's nothing but duality. Wherever and is there, that will become or. Wherever or was there, that will become and. You understand this thing in here. If I change this again, then this became this. You understood, right? Original. Okay, the things are missed here. You can write your own thing. So wherever and or is there, okay, that will become or and like that. Understood, right? This nodes you can see here if you want anything. Okay, just loading it. Now let me just start with the interesting part. That is this thing. What is this? Explain various reasons for failures of first order logic. Define a sample space for picking two tokens from six token of lab questions with token taken first time is not replaced. Okay. Okay, reasons of failures in first logic. I had already explained this, I guess. Now, okay, computational complexity. Okay, reasoning in FOL can be computationally expensive, especially for large known bases. Just remember this. Most important is this expensive. Okay, it's expensive. Exceptions limitations, quantities and concepts. So FOL struggles with quantities or concepts like all, some or few, making it hard to generalize about group of objects. Then a high order logic. FOL cannot, first order logic, FOL means first order logic cannot handle predicates having predicates or functions as arguments. Okay, so some questions are there. That question itself is having these predicates and symbol and all, so which limits its expressiveness compared to higher order logic. Then decidability, logical consequences relation. The logical consequences relation in FOL is semi-decidable. Okay, just understand it cannot be. Ayo, your major not be same stuff. Changes. Okay, no, cancel. Uh, okay. That's only because okay, you are seeing here, right? This thing. Oh, this part. Okay, domain specific issues. Just read this theory part. I'll start with this state space. Main, I think, Here we have this thing, picking two tokens from six tokens, a very simple one. So see here, you remember that question in max, right? You have in fourth module, all the possible divisors for that 72. So you has a diagram also you will be drawing, right? Let me just flash the memory. So that has a diagram or something like this. Okay, one, two, three. You remember, right? So here one, two, three, like that. 4, 6, 9, 8, something like that. Okay, yeah, like that. Okay, like that. You remember for 72, we'll be having like one. For you'll first you'll remove all the possible things to divide, and 2 will divide, 3 will 4 do 40, 60. Yes, 4 will also do. Then 5 not 6, 7 not 8, 9, 10 won't, 11 won't, 12. 13 won't, 14 won't, 15 won't, 16. 16 will, does it do? No. Then 18, 36 and 72 itself. Okay. That thing was there. So here first what will do? Possible pairs. So first 6 tokens. Okay. I am selecting here. Okay. 6 tokens I am selecting without replacement. Same that permutation is here, right? Then the sample space consists of all the possible pairs of tokens. First what you do? First pair A with everyone. Okay. First pair A comma B, A comma C, A comma, it's not, it should not repeat, okay, A comma A cannot take. So A B, A C, A D, A E, A F. Okay, I'll just give one hint. A to F. Then B to B C, B D, B E, B F. Then C D, C E, C F. D E, D F. Then E F. That's it, done. Okay, that's what they have done in this place. Okay, total number of pairs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 are there. Okay, total number of pairs can be calculated using the combination formula. I just leave, you just count, right? Okay, so for n is equals to 6 and k is equals to 2. So here some formula comes for picking up sample tokens. Okay, so the sample space S is equals to a whole thing you're writing here. Then the sample represents all the possible outcomes when picking two tokens from a set of 6 tokens without replacement. Okay. So n is 16, we are talking 5. So here something binomial. So what I was saying, sorry I had to like cut some part due to some notifications. So now what you have to do? Okay, so n is 6 number of tokens. So k sample you are picking 2. So this some formula comes here, factorial of 6 into factorial of k minus okay, that's it's like n factorial into 2 factorial into n minus k factorial, which is equals to, we have to find this. Okay, so what will be n factorial? Okay, let us find 6 factorial, okay, fraction, I think divided by, this will be 6 factorial divided by, here or this will come. So let us solve 6 factorial, 1 into 2 into 3 into, I'll erase this. Okay, 4, 5, 6. Okay, just think a multiplication is there. Then divided by 2 factorial is nothing but 2 itself. 2 into n minus k, 6 minus 2, 4. 4 factorial. Again 1 into 2 into 3 into 4. So 1, 2, 2, 3 is 6, 6, 4 is 24, 24 2 is, what is 24 2 is? Is it 48? Hey, yeah, 24 2 is 48, right? And what do we have in the thing? So what is 6 factorial? Let me just calculate in my mobile. 1 into 2 into 3 into, oh, I'm adding 1 into 2 into 3 into 4 into 5 into 6. It's 720. 720. So let me just divide 720 divided by 48. So I'm getting exactly 15. Hey, yeah, this is the formula then, bro, guys. Okay, even though something blah 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 was written, I got it. Okay, the formula is that's it. N factorial divided by what is that? Sorry, here n won't come. Mm, draw k factorial into n minus k factorial. Remember this for this picking up two tokens from this. Okay, possible outcome whatever it is, you derive it. So it will equal to this. Like that you write last me equal those the sample space S is equals to set of all these things. Just write it and close it. The sample space represents all the possible outcomes when picking two tokens from a set of 6 tokens without replacement. So since it was 15, then so you will write all 15 things. So okay. Uh, do we have anything? Prove all Kolmogorov's probability axioms. Okay, this thing is one kind of a headache type of thing. Okay, so let me just show here. So I'll write Kolmogorov. Ouch. Okay, let me just search. Yeah, we came here. So basically, why do you keep on showing so much, man? I'll be pissed if my voice is not being recorded. Probability axiom and they're reasonable. So first, what we'll say here now. So it starts where you know. Where? Not here, not here. Yeah. See, it starts here. 13.3, yeah. 13.2, 13.1. So what you need to remember is this one. Okay. This thing 0 less than equal to p of w less than equal to 1 for every w and summation of w belongs to omega p of w is equals to 1. Do we have anything before this? No. So just remember this part. Okay. This part. I'm highlighting it so much. Oh, will it become red? Oh, it becomes red, you know. Ah, shit. Whatever. Just remember. So just remember summation of w belongs to omega p of w is equals to 1. Then what it says for any proposition phi pi. Okay. So what it says p, p of phi is equals to summation of w belongs to omega p of w. Okay, so instead of omega, if it is phi, then p of phi is equals to w belongs to omega p of w. Similar itself. Here just instead of equals to 1, we are writing p of phi. Here w, just replace omega with phi and replace 1 with p of phi. Okay, two things. And then this is one normal thing. If you want to remember, you remember it's simple. P of A or B is equals to P of A and B divided by P of B. This actually comes under problem solving. Okay, it's important for us in which is topic, that is marginalization and normalization. I'll talk about that later. Then now I'll go to this part. Get lost, man. Okay, here Kolmogorov's axiom. You can see here, right? How it has. Oh man, seriously. Uh, just record the background when I'm playing. What a mess, man. Okay, I have to merge that video again. Now, fine. So now see here, P of negation A. So now we remember that formula, right? So we know that P of something phi is equals to summation of W belongs to that phi P of W. Okay, same thing. Instead of phi, negation A is there by equation 13.2. So now what I am doing here, P of W belongs to negation of P of W. So see this thing. I'm adding and subtracting the same number. Same thing. Okay. So now next what I'm doing, I have to erase this. Okay. Next what I'm doing is, okay, first see here, this thing here, it is same. It will if I just add and subtract it, it will leave me only this much. Okay, there is no difference when I add this much. So it's like plus 1 minus 1. So now what I'm doing, so I'm keeping minus this as it is. I'm keeping this as it is. Okay, you can see here this is same as this, but what I'm doing, I'm adding this both. Let me highlight it with different color. I'm just adding this 2 and making it as omega over here. You can see, right? So negation A and A. So it's like plus and minus. Everything is included. So negation A and negation A both are included. So by adding this two, what I'll say, W belongs to omega, P of W. So from first equation, we already know that the summation of W belongs to A, P of W is equals to 1. So we'll get 1 minus here. Now see here, we have W belongs to A, P of A. It should be equal to what? So here, instead of 5, I just have A. So it's, I can simply write P of A now. Understood, right? I hope you understood. Nothing else is there now. So how you know how P of A comes here. So that's it. You have to write a probability axiom. And then after that, just write this. P of A or B is equals to P of A plus P of B minus P of A and B. This thing is used for us to solve this thing. Same thing we have here. See, P of A, P of B. Okay, P of A and B is 0, 0. P of A or B is 0.8, like that they have written. Just leave that. Done, right? Probably as times and 7 mark. Given that a bus arriving late is 0.3 and a student oversleeping probability is 0.4. Find the probability that student gets late. Okay. So here what we'll do first. I'll show that here. This guy has done it in a simple way. Yeah, see now. P of, okay, I have to select this drawing thing. Okay, the bus arrives late. The student oversleeps. Both the bus arrives late and the student oversleeps. Okay, let us note. P of bus arrives late is 0.3. P of student oversleeps is 0.4. So assuming these events are independent. So if these events are independent, P of late is equals to P of bus. Probability of late is equals to probability of, it's not bus actually, it is B union S. B union S, okay, where intersection union, remember that. So you know the formula of any A union B. A union B is equals to P of A plus P of B minus P of A intersection B. So this intersection is then equal P of A into P of S. P of B into P of S. So 0.3 is 0. S, that is 0.12. Okay. Then P of B, P of S, you know that already 0.3, 0.4. So you are adding here this P of B, then this P of S minus intersection thing. This thing is same as this. Okay, I can derive like this also. Both are same. Okay. So we'll get this answer. So probability is 0.58 or 58%. Very simple, right? You understood. Then finish. Explain marginalization normative with the full joint distribution. So this is important. Okay. Let me just remove this now and type GOINT joint. Inference using full joint. Wow, perfect. I have come to proper place. Yeah. Now you can see here, right? This. Oh. Okay. This whole table is very important for us right now. Just remember here, this numbers, it's not necessary that you have to write the same perfect exact numbers. Okay, you can take your random numbers, but how to decide, like how to take the numbers. Okay, so you have to decide, right, what numbers you should take. So how will you decide the number? It's quite simple. Okay, So see here, if you add all these numbers, these 8 numbers, the sum should be 1. Just remember that. Just what you do, take your calculator and then divide a number, subtract a number. So, okay, just divide 1 by 8 times. Okay, if I show you, if I do, okay, let me just solve that in calculator. 1 divided by 8. So you will get 0. Let me just write it, 0.125. So now what you can do here? So just write 0.125 8 times. Suppose you have written it 8 times. Then just subtract 20 from this. So it will become 0.105 and add 20 somewhere. So that another thing will become 0.145. Okay, two numbers over. Same way, take it two pairs and just change the number. Or else, better if you learn this, it's fine. So now what they have asked is, explain marginalization normalization with full joint probability distribution. In bracket I given that two take problem like that. So now marginalization. So see here, marginalization. The process is called marginalization or summing. Because we sum up the probabilities for each values of either of the other variables, thereby taking them out by the equation we can. Okay, marginalization is nothing but we take the sum of rows and columns. Okay, that's what it is. So let us here. Uh, Adding the entries in the first row gives the unconditional or marginal probability of cavity. Adding the entries of second row will give unconditional probability of not cavity. This thing. Okay. Let me highlight it now. This and this. Okay. So this thing is nothing but calculating the marginal probability is nothing but marginalization. Okay. Now where is the table? So now let me take another color. Let's take pink and see how it comes. Okay. And if oi, oi, what is this? Let me better erase everything. Wow, man. Now it looks nice, right? Okay. If I add array, okay, leave anyways, ignore. Bro, seriously. Now if I add these things, now you see when I add this 0.008, 0.72. So if I add this 72 and 8, that is 80. Then I have 0.108 and 0.012. If I add 12 in 108, it becomes 0.120. So 0.120 0.120 plus 0.80, so it will become 0.2. Okay, so here I have 0.2. Then this should be 0.8. Okay, these four values should give me 0.8. Obviously if you add, it will be 0.8. Now I'll add, let me add like this, 0.0108 and 0.016. Okay, 108 plus 16, so that is 0.124. Let me just write 0.124. And if I add here 60, 70, 76, 76, and here 144 plus 72, it is 0.216, and here 576 plus 8, so 0.584. Okay, now when I add these things, okay, when I add these values, what is this? Okay, when I add these values, this will give me 1. Okay, you are understanding? Just try to add. It is all point 1 point. Okay, here I forgot to mention this point. So 0.584, 0.216, 0.76, 0.124. This will give me 1. So just what you have to do, okay, it's in right. For row, just take f of y. Okay, sorry, f of x. Okay, for this f of x1, f of x2, suppose I'm taking. Then for this, what I'll do? I'll say g of x1, or else you can say y1 also, g of y2, so like g of y3, g of y4. Separate, and you just give, then you write f of x is equals to f of x1 plus f of x2, which is equals to 1. Then g of x equals g of y1, y2, g of y is equals to y1, y2, then it will give us 1. Like that, you can talk about marginal probability. Now, what is normalization? Normalization is nothing but you have to find the process. Okay, the two values sum to 1 as they should. Notice that in this case, two calculation of them. Okay, no matter which value of cavity we calculate. In fact, if you use a normalization, constant for distribution free. So normalization is nothing but when you add up, right? When you sum up sum. Okay, see here. We have here the probability of cavity and toothache, and here we have the probability of there is a toothache, but it's not a cavity. So when you add these values, okay, you are getting 1. So that is nothing but normalization. No matter what kind of probability, okay, normalization, two things that will here will give you 1 itself. So see here, P of cavity or toothache is equals to, and they are giving alpha P of cavity comma toothache. Okay. Now P of cavity comma toothache comma catch plus P of cavity comma toothache comma not catch. This is come from table itself. I'll show you how it is taken from table. See, toothache, this part, toothache cavity catch, toothache cavity catch, toothache cavity, okay, then not catch. Same way, toothache not cavity catch, toothache not cavity not catch. That will come here. Okay, see here, cavity toothache catch, cavity toothache not catch. You just have to add the values. How you will add these values from the given table? Cavity toothache and catch, no. So what you will do, you will add only these two values, 0.108 and 0.016. If you see here, it's the same, 0.108, 106. Not catch means just the table, this here, these two you will write, okay, 0.012 and 0.064. Okay, and what will it give? Alpha of 0.012 comma 0.018. Here what you can do, you can cancel, scratch, right, divide by 2, both can be divided by 2, by 2 by 2. So 2 will go 0.4 times, 2 will go 0.6 times, and ultimately you are getting this, which is equal to 1. So you can talk like this and leave about normalization. Then what you have, this thing very easy one. Okay, write the representation of Bayes theorem in the class of 70% zero. Okay, wait, this thing same to same thing already in textbook they have given the answer. Let me just search that. So that thing was, okay, BAYE, Bayes rule. Yeah, okay, it will come somewhere here. See here. Okay, Bayes rule, Bayes rule, Bayes rule. Yeah, see here. This thing. This. Yeah, array. No. What's the problem with this? Okay, till here. So now see here. We'll read this. Okay, once we'll read it. On the surface, Bayes rule does not seem very useful. Okay, because see here, they are giving this kind of what to say, normal thing. It's very simple. If there was a book, okay, see, it's already here. P of A and B can be written as P of A or B, comma P of B. So basically, first what it says, let me draw here. Just draw. So P of A or B can be written as P of A. Okay, P of A. So P of A and B can be written as P of A and P of B. P of A into P of B. But I am writing this P of A in the form of this. That's it, they have written here, this wala. Okay, and P of A and B can also be written as P of B or A and P of A. So instead of writing B, I am writing P of B or A, and then I am multiplying here like this. Same, right? Then here P of B or A can be written as. So this thing will become P of A. Okay, so what will happen here? This is also P of A. This is also P of A. Both will get cancelled and remaining P of B itself. So simply see, instead of one thing, we are writing three things. It can be written in three parts. So that's what it's saying here. So simply, if your base rule does not seem very useful on the surface, but because simply one thing is written into three forms, it allows us to compute a single term P of B or A in terms of three terms. See, P of B or A can be written as P of A or B, P of B, P of and P of A. Okay, this can be written in this term. So this seems like two steps backward, but base rule is useful in practice because there are many cases where we do have a good probability estimate. So here, if you are having a good probability estimation, then it's very useful. What you have to remember? Only this formula you have to remember. Yeah, okay, P of B or A is equals to P of A or B and into P of B divided by P of A. So now see here, applying base rule, the simple case. On the surface, okay, they said etc. Now the condition probability. Okay, so here what you're doing, say, okay, cause, effect, desired diagnosis. So here, okay, first let us read the question. Write the representation of Bayes theorem in a class. 70% children were fall sick due to viral fever. Okay, uh, fall sick. Okay, P of C you can say. Let me see in the textbook. Now they have given 70% of children. So 0.7. Okay. For the P of S or M. Here, what is M? Symptoms or disease is equals to 0.7. Okay. Due to viral fever and 30% due to bacterial fever. The probability of observing temperature for viral is 0.78 and for bacterial is 0.31. If a child develops high temperature, find the child's probability of having viral infection. Okay, that's what we are doing here. So now what we are, so here's also same thing they have given. So instead of the doctor knows that some unconditional fact, the prior probability is that is a patient has meningitis. Instead of viral fever, we have meningitis is 1 by 150, 1 by 50,000. And the prior probability that any patient has stiff neck is 1%. Okay. So here they are saying, so instead of P of M, P of S, what do we have P of M? P of viral fever is 0.78. In this case, we have P of M is equals to 1 by this. Then P of S is 0.37. Okay. Instead of 0.01, we have that. So now how we will do? Probability of, okay. So probability of, find the child's probability having viral infection. So first what we will write, effect, here you have fall 6 due to viral fever. So you just have to represent in such a way, S by M. So okay, symptoms by disease. You have to find M by S. So what is it asking for us to find? Find the child's probability of having viral infection. So you can just write that here V. So just a second, I have to find. So parents have, okay. So here this won't come. 1 minute, I'm sorry. If I once write this, I just have to find a way. So fall sick, viral fever, viral infection. So viral infection, viral fever. Okay. So P of viral fever by viral infection, they have given 0.7. Okay. I will now what I will do. I'll just write here. Instead of S, I have VF. Instead of M, I have VI, viral infection, viral fever, which is 0.7. P of M, that is P of viral fever, only viral fever is how much they have given? 7, wait, let me just check again. 7, 8. Okay, 7, 8. Then here 3, 1. P of what it is? Bacteria. Okay, now what I can do simply, I have to multiply 0.7 into 0.78 divided by 0.31. Okay, let me just calculate this in mobile. Even you do in mobile if you want. 0.7 into 0.78 is equals to, so I am getting 0.546. Whenever I try to write 5, it becomes 3 divided by 0.31. divided by 0.31. So I am getting the probability 1.7 something like that. Wait, 0.78. Okay, 0. Fall 6 due to viral fever and 30% fall due to bacteria. Array, that's 0.3, right? The probability of observing temperatures for viral is 0.78 and for bacterial is 0.3. If a child develops high temperature, find the child's probability of having viral infection, not bacterial infection. So let us just try instead of 7, 8 and 3, 1, let us just try to take 7 itself. So what it is saying, probability 70% in a class, 70% children were fall sick due to viral fever. Okay, and 30%. Okay, so P of viral fever is 0.78 and P of bacterial is 0.31. If a child develops high fever, find the child's probability of having viral infection. And this thing got tricky over here. So P of S comma M, it's not there. If I take this as just 0.7 and just this as 0.3, okay, I have to find the other remaining values. Let's see how he has done here. Okay, so here, what is A, what is B? AB is equals to B or A into P of A divided by P of B. Given P of viral is okay, P of bacteria is 30. B of temperature by, okay, temperature or V is 0.78, P of temperature or V is 0.31. So we have to find P of viral infection and temperature. So that can be written as, so we don't know what is P of T. So to find P of T, we can write P of V or T is equals to P of T or V into P of V divided by P of T. Now I have to find P of T. P of T can be written as P of T or V into P of V plus P of T or V into P of V. So I know that these things are given here. Okay, so I have to add, so this into this plus this into this. So I get the probability this. So now simply I'll substitute 0.78 into 0.70 divided by 0.69, that is 0.8, almost 85.4%. Okay, then you have explained the role of probability in solving problems of Compass world. Uh, Here I think I have written here, right? You just see here, first order logic in Compass world. First order logic in Compass world. Oh, same thing. Last 3 pages. Okay, nothing much is there. So you understood, right? So let me just explain once again here in this what it is saying. So see here, according to question. So this thing which I have written here, okay, according to question, this is 0.78 is nothing but probability of. Wait, let me erase this. Okay, probability of viral infection due to this temperature is, what is that? 78.78. Am I right? That's what he has done here. Viral infection, where did it go? See, okay, viral, okay, V by T, sorry, I wrote ulta then here. Via VT, right? T by V should, here T should be there, and here V will come. Temperature causing viral infection is 0.78. Similarly, temperature causing bacterial infection is, what is that? 0.31. Okay, so now I have to calculate V by this one. So this thing I can write as, where is in textbook I told you, right? See here, P of y bar x can be written as P of x bar y into P of y divided by P of x. So now this can be written as, now uh, just I have a P of t bar y. So P of t bar v into P of v divided by P of t. So we already know T bar V is 0.78, and we also know P of V is 70%. So true thing, but we don't know P of t. So P of t can be written as okay, probability of, you see here in textbook I'll show. So only one thing, P of t, if I have to find only one thing, how I'll do. So here how he has taken. P of t can be written as probability of t or v into P of v plus probability of t or b into T of v, probability of temperature. Okay, T by v also should be there and T by b also should be there here. Probability of T is equals to. And here we are multiplying this into P and V type, right? So T into V. Temperature, complete temperature, T into V plus T into B. This thing and this thing should be added. Okay, simple, right? So it's simple like 0.78 we'll multiply with 0.7, 0.31 will be multiplied with this, and this both will be added. You will get that value and you will solve, and this completes your model paper. I'm exhausted, I'm going to sleep.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.